So now it's time to talk about functions. Functions are the backbone to your application. They're actually really cool because they help us execute things over and over and over again, right? So we've already kind of figured out how to use a loop to parse out data, but what a function can do is call that loop many, many times. Now this is going to make a lot more sense once we actually jump into it, but before we do, we're going to talk a little bit more about lists, and then we'll jump into actually defining our own functions. So let's go ahead and get started. What we're going to do now is define a mixed use list. That is a list with strings and integers, and then we're going to do that for loop again and parse that data into two different kinds of strings, and then we'll actually define a function. So first off, let's do some stuff with strings though. And I'm going to say items equals to, and I'm going to say mic, and then phone, and then some random number, or a random decimal number, so number with decimal places, basically. Some other things like a name, bag, whatever. It doesn't really matter what we're saying here. It's just mostly the fact that it is mixed between integers, decimal integers, as well as strings. So we do that, we see items here. Now, we have that for loop that we talked about before where we actually pulled out items based on what they were, what type that they were. So what we're going to do now is discover a few things with that prior to actually jumping in the for loop. So what we see here is actually a float number and an integer. So float numbers and decimals are close to being the same. They're just slightly different data types, but basically know that if it has a decimal and then numbers after it, that's considered a float number. So we can check that by doing is instance and then write out a float number, and we could say int for integer. It'll say false. If we go up and we do float, it'll say true. So our parsing of this list will actually make a difference here. So before I actually go through that for loop and parse it, let's actually do some things with a list that we might want to do. First of all, we might want to actually sort lists. We might want to have them being sorted in some sort of way. Now, there's actually a function built in called sort. But if I hit enter, it's going to say unorderable types, float less than string. So we talked about the float number, and that's this. But even if it would only have integers and strings, it's still not going to sort in the way that we might want it, right? Because there's really no logical way to sort numbers and strings. So numbers and characters. I can't really alphabetize those things. So instead, I'm going to make a new list, and we'll say string items equals to, and I'll just say ABC, JM, ED, and just some random other characters, right? Okay, so, and then I'll do some lowercase ones as well to illustrate a few points here. So if I do string items, again, I see that they're there, and if I do dot sort this time, I can see string items is, string items, str items, is now sorted, but it's not sorted in the way that you might expect. In fact, it's sorted by alphabetical in respect to their actual casing, right? So AD capitalized is the first in this list because it's first off sorting everything that's capitalized, and then it's sorting everything after that. So to actually overcome this, we can do string items and then sort, and then we'll do key equals to str.lower. And now if we see str items, we now see them sorted alphabetically. And this will definitely work for English characters. It might not work for other characters, but it'll definitely work for English characters. So we see here is AAA, ABC, and so on. It's sorted correctly. So that's kind of nice to know. There's one more thing that we can actually add this if we wanted it in reverse. We just add the reverse parameter, and we say reverse equals to true. And that will actually reverse this list. Cool. So what you might be wondering is, hey, but it's actually sorting this particular list, but what if I wanted to sort a different sort of list? Meaning, what if I didn't want to sort my original list, but I wanted to have a new list that's based off my original list, but sorted? So let's go ahead and see that. I'll do sort items, and then I'll do new items equals to, and we'll just do sorted. This is a built-in Python function, and then we do str items. I press enter and do new items, and now it does that same sort of sort that we saw before without that key. So new items is actually that original sort right up here. So what we can do now is also add those same things, and that's key str.lower, and then reverse equals to true, and then we do new items again. Now we've got new items being sorted in reverse alphabetical order, and then our str items is still the original list. So that's kind of cool as far as sorting is concerned for strings. Now, what if we wanted to sort for numbers? Well, let's go ahead and make a new list called int items, and I'm going to just put in some integers in here, as well as decimal or float numbers, and then we'll come in and just add in some stuff. Okay, so now we got int items, and the same thing's true. If I do sort, I see int items. It will actually sort them by smallest to lowest, and if I did sort reverse equals to true, it's now largest. It's going to be largest to smallest. And then the sorted thing is still works on this as well. So new sort equals to int items, and that is sorted int items. Let's do that again. So new items equals to sorted int items, and we could say reverse equals to true. And new items will be the reverse of this. And it looks like we might have done it twice, so we'll say new items and int items. So in this case, we actually discovered something that's kind of cool. It's not intuitive, at least it's not the expected behavior, right? So when we did reverse equals to true, it's not actually reversing that list. It's reversing based off of whatever's in that list, right? So first of all, it's sorting those items, and then it's going to reverse that order. So when we did reverse equals to false, it actually sorts them smallest to lowest. So this reverse call has almost nothing to do with the actual list that it's sorting. It actually has to do with the items inside of that list. So it sorts the items first, and then it reverses them or not. And so that's how that sorted function works. Cool. So from here, we can actually do some stuff in addition to lists with numbers in particular. So int items are numbers. So we can actually calculate and bring all those numbers together by using the sum method. So sum int items, and it actually combines them, so it adds them together, right? So that's a function that's built in. And then we can also do the length of it, right? We've seen this before. So length of items gives us 5. So this also means that I can actually average these items out. So I'll say total equals to sum of int items, and then the average equals to the total divided by the length of int items. So the average, oops, I spelled average wrong. Average, the weird average, is this, right? So this is on Python 3. So let's actually look at Python 2 to see the slight difference, and we'll talk about how to actually fix it. So Python 2, we're going to take those same numbers, and we're going to grab int items here. And then we will do the total is the sum of those int items, and then we'll do average number equals to the total divided by the length of that, and then we do average number, and we get that same average number. Now, this is true for the fact that we have a float number in here. So let's try it with a whole nother one, and I'll say instead of int items, I'll actually do a sum or a total that is not a float number itself. So instead of actually going through a whole new list, I'll just give a new number, and we'll say average number 2 equals to, some number, and then the length of int items. And now we see average number 2, and it gives us a rounded number. Let's try that exact same thing in Python 3. Average number 2, and we get the rounded number. So this is an example of when we want to use a float inside of this actual equation here. So we're going to do average number 2 is now equal to that number divided by parentheses. We'll do length of int items, and then we'll multiply that by 1.0, and then we'll do average number 2, and it gives us out this average number. So these are slight little things that are different about Python 2 and Python 3, but when you're designing your programs, you want to make sure that you're doing stuff like this, just so it works on either one because of how you're wanting to support your programs. Now, if you were just only working with Python 3, this will work fine, but again, this is kind of that fail-safe for either version. And this is definitely something that you'll see in a lot of tutorials, but also a lot of packages or Python modules that will actually do this. Cool, so now we've actually seen more about lists, and we've seen some built-in functions that do some things for us.